What is the minimum amount of components that it'll take to make this little Northern Electric Baby Champ work again? Well, in this video, we're going to find out together, and I'll take you through the troubleshooting procedure as well. Let's get started. This very collectible Northern Electric Baby Champ radio receiver is in nice condition. If you're looking to purchase an All-American 5 or All-American 6 style radio receiver like this, the things to look for would be, first thing, appearance, cracks in the bakelite. So over time, a lot of people lift these radios like this, or they'll drop something on top of them and they'll develop a crack in the bakelite. Bakelite is very brittle. It can be fixed. Like if there is a crack, you really like the radio receiver and there's a crack in it, a lot of the times what I'll do is I'll glue the crack, and then I'll usually, I guess you could say, grind out the center where it's glued a bit, and then put body filler in there and then prime it and paint it. And you can make it invisible, completely invisible. So a little bit of work, but of course, if you're going to be doing something like that, you're going to really be liking the radio receiver. So I always try to look for a radio receiver with, pretty much flawless bakelite. It's a nice start there. Somebody has over time replaced one of the knobs on this. So as you can see, they are mismatched. They did a nice job in finding a knob that's very close. So one of them is mismatched on this radio receiver. Northern Electric is actually a very high quality radio receiver for its time, and I'll show you the aspects here in a moment when we try this thing out and take a look at the circuitry here. So you can see on the bottom here, it has a little label, very standard for these. Nice thing to have this intact. This one is in very good condition. Look at this here. You don't see that very often. So way back when, that was very common, but not so much anymore. So this is the Model 5500 from 1951, or around, very close to. In the backside here, you can see the filter can. Look at this line cord. That's pretty sketchy looking, isn't it? So on my end here, I have an isolation transformer and a current limited Variac supply. So I can bring this up slowly. It has some dim bulbs on the top. I'll show you that here in a moment. And it's isolated. So this is an All-American 5 style radio receiver, which means that this has no transformer. It's a transformerless set. This transformer is for the speaker. So when they say transformerless set, they're talking about the power transformer. So this is known as a series set. The old Christmas lights used to all be in series, and it's like this radio receiver here. All the vacuum tube filaments are in series, so if one of the filaments burns out, they all won't glow. So you have to find out which particular vacuum tube has the burnt out filament. So pins 3 and 4 on most of these tubes here are the filament pins, and it can just be a simple continuity test in order to find that out. Getting back to the chassis here, so this is known as a hot chassis set. So whenever these are restored, it's always advisable to put a polarized line cord on here, and I do a switch modification in here in order to keep the chassis close to the neutral side. Now I talk about this in many other restoration videos that I have. This is just a resurrection video. I'm going to take a look at this radio receiver, display how pretty much easy it is to make one of these things work again, and then I'll talk about what really needs to be done in order to bring a radio receiver like this, I guess you could say, up to safety specs or closer to safety specs today. So there are limitations, of course, in the design itself. So if you're following along, you're doing so at your own risk. Know the risks and the dangers of working on a hot chassis set. Again, I have a lot of videos here on YouTube talking about the safety aspect of these radio receivers. You can check out my other videos just by clicking on the videos tab underneath on my main page, and you'll find a lot of All-American 5 restorations where I convert these things completely to a very safe set, fuse them and everything, even add Bluetooth to them if you're interested in that as well. Again, all here just under my videos tab. So another interesting thing about this radio receiver is it doesn't have a back. These never came with a back. So this is the antenna that's wrapped around the case here, and it's just soldered to these two tabs right here. So it's very easy to remove the chassis on a radio receiver like this. Basically just remove the screws and pull the knobs off, and basically you're inside. So what I'm going to do is plug this in to my current limited isolation transformer and Variac supply. What I'll do is I'll make sure the switch is on. it is on. Make sure the volume is down. So when I flip the switch right here, you'll see these bulbs somewhat light up. So I'll start down here a little bit and make sure this is in current limit, which it is. So that's current limit there. I'll just flip this on. Bring that right to the top. And it's not getting bright, so they should glow just dimly like this. And it's not getting super bright. So that's a good sign. Let's see if the actual radio itself is on. Turn the lights down here. Oh, it's crackling, so it is. That's all it's doing. So that's it. Tubes are lighting up. So that's not doing too much. So it definitely needs some help. Full volume. Nothing happening. All right, so I'll shut that off. So of course I'm shutting this off at the current limited isolation transformer variac supply. So even when I shut that off, both sides of the line cord here are disconnected. So it's completely disconnected. So at this point, it's safe for me to, touch the chassis. There's no problems with that. Again, an isolation transformer is very important when you're working on anything like this. Again, a hot chassis set. I talk about this in many of my other videos. Now, again, this is just a resurrection video, so we'll see what it'll take just to make this work. And I'll talk about what's actually needed to make this very dependable over time. So the next thing I need to do is get this thing out of the case here. So what I'm going to do, so I don't damage this antenna here, is I'm going to heat up a soldering iron and I'm going to open up the antenna here and remove the screws and take the knobs off, and I'll show you that process. Okay, so what I'll do is I'll add some solder to this in order to remove the solder. You're probably saying, what? Why are you adding to remove? Well, adding solder a lot of the times makes it quite a bit easier. This old solder has dust on it and all sorts of stuff here. So by adding a bit of fresh solder makes things quite a bit easier. You also want to take note of which antenna wires go where. So both wires go to this terminal and then a single wire goes to this one over here. So what they've done is they've wire wrapped this a little bit. So what I do is I try and find out which way they've wire wrapped it, which they've done here, like so. And just remove it, like so. The antenna wires are now removed from the terminals here. The next step in removing the chassis from the case here would be to remove the knobs and the pointer. So these usually just pull forward, and they do just like so. Depending on the particular style of radio, sometimes there is a set screw. So that has to be looked for, but this is pretty common for this style of radio receiver. Basically just a tensioning ring here, and they put a little cut in the knob here itself, and that squeezes onto the half shaft here. So pretty easy. They did a nice job in finding two knobs, that are relatively close. So there must have been a bit of research and time into that, trying to make that look okay. The next would be to pull the dial pointer off. That'll be the same. Again, sometimes there is a set screw. There isn't one on this. That just pulls forward. You'll also notice in a radio receiver like this, there is no index. So in order to set the pointer alignment, it's very easy. So there's just enough friction here on the shaft that you can move this around to the correct position. So basically, to align this, you would turn the dial pointer as far as it would go this way and then turn it right until it points to 55, and then tune the dial and move the dial pointer back over to this side and make sure that it points to 16 or 1600 AM. If not, you can slide this around until the travel is even between the two and very easy to align. So that's kind of nice. So having that friction area there. Now, the next step is to put this radio on its face on a soft mat. So this mat is very, very soft. So I can lay this forward on its face without damaging anything. So soft mat, towel, whatever is okay. And now just remove the 4 screws from the bottom and the chassis should just come out. All right, the chassis is ready to come out. So I'll just tip this back like so and move this out. Of course, the antenna wires and everything are going to want to catch everything. Again, being careful of the paper on the speaker as well. It's very easy to pierce, so you want to be careful around that. Look at all the dust. That's antique dust right there. Probably all from 1951. All right, 1951 was a very dusty time. So on the bottom side, let's take a look at what we have going on in here. Look at these capacitors. So these are known as paper and foil type capacitors, not paper in oil. That's a common mistake. Paper in oil capacitors are a little bit different than this. These are paper and foil. And they've been so hot that they've bubbled. So there's bubbles all over the place. Look at this. All little bubbles. Wax bubbles there. So this is a common failure point in a radio receiver like this. Again, they've been so hot that they've boiled, basically. So lots of issues there. In order to begin troubleshooting, what I need to do is attach the antenna from the radio receiver back up to the radio again. So I'm going to do that with some jumper clips. Now, the length of the jumper clips really isn't all that incredibly important with a broadcast band radio receiver, but higher frequency radio receivers, lead length does become important. Again, this is relatively low frequency, right? So not too big of a deal. This will just act as more of an antenna. What I'll do is I'll turn the isolation transformer and current limited variac supply on and let this warm up for just a moment. I'm ready to start troubleshooting the radio receiver, so what I want to do is listen around in the chassis for a bunch of various different signals and see if there's anything happening with the oscillator or the IF stage or anything like that. So what I'm going to do is connect the common of the ultra probe to the radio's negative. So that's the radio's negative. So the chassis ground and the radio's B minus are actually two separate grounds. So this, consider the chassis like an RF ground, and the B minus in here is attached to the filter can. So that's what the ultra probe is attached to. The very first thing I want to do is take a listen to see if the oscillator is working in this radio receiver. So I'll turn this on. So this is a very, very sensitive device. I'm hearing a radio station in here already. So the probe is picking this up from just laying here. So the radio itself is obviously working because it's hearing a radio station come out of this radio receiver right now. So signal there, but nothing coming out of the radio receiver. I didn't even have to go over to the oscillator, just laying on the bench. It's hearing this thing is working. So anyways, it's kind of diagnosed it already. So I'll run you through what I was going to do and show you what happened. That's how easy this thing makes troubleshooting. This is another device that I've designed and released in my electronics course. All the plans to build this thing are there. This is known as the Ultra Probe, not to be confused with the Super Probe. This is a much more sensitive device. As you can see, the probe's just laying on the bench and it is already telling me that so it's already telling me that the radio is working just by sitting here on the bench. So anyways, very neat project. It also listens to mechanical noise as well. So to give you an example. All right, so you can listen to bearings and all sorts of other things with this, but that will be in another video. I've never really displayed the full capabilities of this thing, but I will do that in a future video. So anyways, to see if the oscillator is running in a radio like this using the Ultra Probe, you just go close to the oscillator coil and there should be a rushing noise. Hear that? You can see the indicator come on. So that right there tells me that the oscillator is running. So I know that the oscillator section in this radio is working. The volume is maxed out, but of course we still have nothing coming out. So what I'm going to do is just go to the output of the converter tube. So that would be, if I grab the schematic over here. So what I'm going to do is go to the output of the, I don't know if this is a little bit too bright here. What I'll do is, yeah, it's not so bad there. So what I'll do is I'll go to the output of the converter tube. So we see that the oscillator is running, right? I put the probe lead close to the oscillator coil. You can see that that's running. So if we're going to be receiving a radio station, we're going to hear it at the first IF transformer right at the output here. So that would indicate that the first stage is working, the oscillator, and basically the output to the first IF transformer is working. So what I'll do is I'll turn this up. So you can hear that the first stage is working. So we know that that is working. So now what we want to do is go to the second IF transformer. It should be louder at the second IF transformer because we have an amplifier here. So I'll turn this up again. So I can get quite a ways away from this and still hear the signal. So you can see that we have amplification from the first to this, you know, from basically from the converter tube to the IF the first IF, right? And the output of the first IF here. All right, so we can see that that's working, but somewhere between the audio, if I turn this off, you can hear there's no audio there. So somewhere between the last IF transformer here where the detection is and the audio output transformer is where we're losing signal. So that would lead me to now question, is there any plate voltage at the 12AV6 and any plate voltage at the 50C5? So the next thing I'll do is I will check that out. So the Ultra Probe just led us right to the audio output section here. Technically, if I go to the audio output tube itself, I can see if there's anything there. So a little bit, but not much. If I go to one tube back to the audio amp tube, that's the audio amp tube. And that's the audio output. So I don't know if I can show this to you here. So I can see that, I'll move this out of the way. So I can see that from here to here we have no audio. So it's pointing us to the fact that the audio stage is probably working, but we have nothing at this point right here. So we've actually worked our way right over to this section, but I'll take a plate voltage reading anyways, since we're in this area, just to see if the plate voltage is here, and then we'll check the 50C5 as well. I have a DMM attached to the radio's B- now, so the negative of my DMM is to the B- rail of the radio. I'm going to take the positive probe of my DMM and look for plate voltage or anode voltage at the 12AV6 here. So that's at pin 7. They're nice enough to mark the pin numbers here. So in order to find pin 7, there's an opening between two pins of the vacuum tube. That's the index. And you count clockwise from the opening to pin 7, which is the very last pin because it's a 7-pin tube and we should have plate voltage. And there is. It's low because I have the dim bulbs in line right now, but that's absolutely fine. We also heard through the ultra probe that we had quite a bit of amplification at this stage here, so we know that that's working. But yet the volume control is at max, we've got crackling, and there's nothing at the audio output. So the next area that we want to check is at the control grid of the 50C5. This is where the signal comes in. The audio should be present here. So we get audio amplification here. We have detection with the two diode plates here, and we have audio amplification at the plate of the 12AV6. So that audio should go through this capacitor and into the control grid. The capacitor is here to block the DC from the plate. We don't want to put DC on the control grid of the tube, because if we do, what we're going to do is positive bias this tube, and it's going to turn that tube on and cause issues with the audio output transformer and all sorts of other things. So let's see what the voltage is at the control grid, or pin 2. I believe that's pin 2. Yes, pin 2 of the 50C5. So pin 2 should be 1, 2. That's this pin right here. And we should have close to no voltage there at all. And as you can see, I've got 1.5 volts. That's way too high. Way too high. You know, the crackling in there. It's crackling away. So now, there's a pin inside, there's actually two pins that connect to the control grid here of the 50C5. So we have pin 2 and pin 5, and they both attach to a positive source. So we have a connection here through a capacitor back to pin 5 from the plate of the 50C5, which could be leaking. This cap could be leaking here, or the capacitor in the couplet could be leaking DC across it. So when you hear me saying the term leaking capacitor, I'm not talking about physically leaking, I'm talking about electrically leaking. So capacitors are only supposed to pass the signal AC through, but not pass the DC through. So one of these capacitors is most likely going to be bad. Now, I'm going to check this cap first. Why, you may ask? Well, this capacitor sees a much rougher life than this capacitor does because it's attached to the plate side of the 50C5. There's some pretty big signal here when the radio is working. So couplets rarely fail, this is the couplet right here. So there's a whole bunch of capacitors and resistors in here. This is basically an early integrated circuit. Passive integrated circuit, mind you. But it's basically an early IC if you want to look at it like that. Back in 1951, you can see all the components inside the couplet, kind of washing out here because of the lamp. But I'll turn that down just a touch so it's not going to wash it out so bad. But you can see here, this is what's inside that couplet. This little thing right here is this here. Again, the capacitors in this very rarely fail. So I'm going to check this one first. And that runs from pin 5 right here, which would be this capacitor right here. This is a mica cap. Now, micas rarely fail as well, but that mica is seeing a much rougher life, again, than this couplet capacitor. So what I'm going to do is desolder one leg of this cap. It won't affect the radio receiver at all by removing this. You can basically look at this like some form of feedback here. It'll also affect the tone of the radio receiver, but this is a form of feedback. So what I'm going to do is just remove one leg and see what happens. See if we get any radio station back by opening that capacitor up. This is the capacitor here in question. So what I'm going to do is desolder this one leg right here, and that should allow me to open that capacitor up. So I've got my desoldering tool warm here. This is going to block it. I really can't really show you, but what I'm going to do is get in there and vacuum that just like so. So what I'll do is I'll get this down here on the pin. Vacuum some of the solder off that. And it's very common for the radio companies and whoever puts these radios together way back in the day in the manufacturing to fold the leads around so they kind of have a curl in them. So what I'm going to do is, with a pair of snips here, I'm going to go in there and try to just, I guess you could say, very carefully get the snips around the lead and allow myself to pry the lead away from the tube socket. I did, and it's working a-okay here. So since it's actually loose, managed to get that loose, what I'm going to do is take a pair of pliers now, because I don't want to damage the lead on the cap just in case I'm going to reattach it again. So I'll just bend the lead straight, like so. And if I pull this out of here, I don't know if you can see that. It's really hard to see with my hand in the way, isn't it? So I can just pull this out now. Get that out of the way so that capacitor is now open and out of the way. So now that that is, I'll just adjust the focus here, and there. Now that that's out of the way, we'll move this back like so we can see what's going on again. And I will turn on my isolation transformer and current limited variac supply again, and we'll see what happens here. So we'll let the radio warm up, and maybe we'll get some, volume is at its max, yes. See if we can hear any radio stations or anything. Still sounds pretty silent, doesn't it? Sounds very silent. So we may have more going on than just that in the radio receiver. So let's see if that changed anything now. Move this back over here, and we'll see if that bumped the voltage down, or see if that helped out a little bit. Oh, I'm actually hearing a radio station in there right now. Oh, I don't know if you can hear that. It's actually starting to play a radio station just before we check it.
Oh.
It's coming to life.
Electric hybrid vehicles are driving innovation.
So no problems. So that looks like that could have been the issue. Just took a little longer to warm up because the dim bulbs, I guess, and dirty control. So that was most likely the issue here. Let's take a reading of the control grid again. And that's how it should be. There's nothing there. Basically nothing. You can see that it's not almost changing at all. So that mica was the issue. So there it is. It's actually alive. So now if I'm going to turn the volume down, and I'll bridge out the dim bulb, so that'll make the AC line come up and everything will really come to life here. So I'll bridge that out. Wow, that is loud now.
Saturday, July 26th.
So yeah, it's full control now, full volume.
Cloudy. That's what's making news right now.
So even with all these old parts in here, really it was one part that stopped this radio from working. What I'll do is I'm going to turn this off for just a moment, and I'm going to go grab a little bit of contact cleaner. So this is off and disconnected right now. I'll remove this chunk of fuzz and give that a shot. And then what I do is I move the control up and down a whole bunch of times. So tapping the end stops. And then do it one more time. There, and now that's much, much smoother. Okay, so I'll turn the volume down now. It's going to be leaking cleaner all over the place here. It'll probably make my bench all wet here in a moment. All right, I'll turn that on. The volume is down. Let this warm up for just 1 second again, and that'll probably make quite a bit of difference with the volume control. I was feeling pretty crunchy there. Turn that up just a little bit. Yep, it's coming in.
They have blocked the left lane from one work that had
Yeah.
And then you've got some work on that first
So much better.
bridge. That is going to cause a delay for you to get to the.
So no problems there. Lots and lots of volume.
Brought to you, your traffic is brought to you by.
So one component, that's all it was. We've got some spray on here as well. So this capacitor was the failure point in this radio. That's what stopped this entire radio from working. Even though all the rest of these capacitors definitely need replacement, it was that one part. So what I'll do is I'll just turn this up and over here. So I'll move this over like so. And you can take a listen.
Might wonder.
Federal Way into Tacoma on I-5. So let's get together and let's thrive.
Once you have an idea of what you want to do, I never was.
It actually receives very well for just one component. And technically we haven't even replaced anything. We've just removed a component, and listen to how well this sounds. So that's all it took. So one faulty, I'll just shut the isolation transformer and current limited variac supply off. So one faulty capacitor, which would be this mica right here. Now, again, micas rarely fail, but this one is in an area that sees a pretty rough life. Again, it's attached to the plate side of the audio output transformer, and there's some pretty big signal there. So there's a good chance that this capacitor could fail, especially if this capacitor here is bad. And of course, we know that all of these are all blistered up, so there's a really good chance that the actual snubber itself is open. If the snubber is open, this mica is going to really be feeling the brunt of the spikes on the plate side of the 50C5, and that's most likely the failure point. Again, really all the capacitors in this unit need to be changed. This other mica will probably be okay, but all the paper, the paper and foil type wax capacitors all need to go. The filter capacitor is working very well in this. That should technically be replaced as well, but that filter can is working very well. There's almost no hum in this radio receiver at all. So there you go, that's all it took. One capacitor, not even replaced, just opened. For those of you interested in seeing this capacitor tested, I have my leakage tester across this capacitor here. I'll put the capacitor tester into test mode, and as you can see, it is extremely bad. This should have gone zip, zip through both scales, and this should have been green within moments, seconds. So what I'll do is I'll open the test lead and give you an example of how that should have looked. This is only 150 picofarad, so that would have been an immediate response there. That's how it should have looked, right there. So I'll attach the lead back up, and it's so incredibly bad it doesn't even move off of the very first LED, which means that this is in the very low megohms, the leakage resistance of that capacitor. This tester tests for parallel resistance. You've heard of equivalent series resistance testers or ESR testers. This is a parallel resistance tester. So what this does is this looks for a fictitious resistor across the component or in parallel with it, where an ESR tester looks for a fictitious resistor in series with the component. This tester here is part of my electronics course. I've released all the plans and everything to build this, right down to even drilling the holes in a nice uniform fashion on the face of the tester here. So it's all up in my electronics course if you're interested in building the Carlson low voltage leakage tester right here. If you're enjoying my videos, definitely subscribe and hang around. I've got lots of great videos coming involving electronics, new and antique, like what you see here. So there'll be a lot of circuitry design videos, restoration videos, troubleshooting, repair, all of that great stuff involving electronics. If you're interested in taking your electronics knowledge to the next level and learning electronics in a very different and a very effective way, I have an ongoing electronics course. I've been on Patreon for a very long time, and there's over 220 videos there for you to learn from. There's a lot of circuits for you to build, all sorts of great things up there. You definitely have to check it out if you haven't been there before. I'll put the link just below the video's description under the Show More tab, and I'll pin the link at the top of the comment section. So click on the link, it'll take you right there. I even share many of my own personal designs up there, many of the test equipment pieces that you've seen on this channel in the past. Lots of great footage there. Okay, until next time, take care and bye for now.